we're going to be computing the future value of a compound interest problem. This is the general formula to find the future value of a compound interest problem. A equals P 1 plus I to the n. A is the future value of either an investment or a loan. P is the present value of an investment or a loan. I is the periodic interest rate. To find I, we're going to have to take the rate, the annual rate, and divide it by the number of compoundings per year, because we want the rate per period, per compounding period, rather than at an annual rate. Okay, so compoundings are the number of times that your interest is added to your principal. If it's compounded annually, that's once a year. Semi-annually is twice a year. Quarterly is 4 times a year. And monthly is 12 times a year. The n is the total number of compoundings. To find n, it's the total number of compoundings not in 1 year, but over the entire term of the loan or the investment. So what you would have to do is take the number of years and multiply that by the number of compoundings per year. So that's your general formula for a compound interest problem. So I'd like to try an example of this now. And we'll try this example. Nicole takes out a $4,000 loan. She will be charged 6% interest compounded quarterly on the loan. How much will Nicole owe after 3 years? So we know our main formula. A equals P 1 plus I to the n. We're looking for the future value. How much will Nicole owe at the end of the 3-year loan? So solving for A, we have a principal amount, the original amount of the loan, which was $4,000. The interest rate is 6%, but this is compounded quarterly. So this is an annual rate, and this is how much she would be charged for an entire year. But quarterly interest is added to her loan. So to find the periodic interest rate I, we're going to take that 6% and divide it by 4 for 4 compoundings a year, since it's compounded quarterly. That'll be 0.06 divided by 4, which is going to give us 0.015. So here we'll have 0.015 for our I value. Now for n is the total number of compoundings. So we're going to take the number of years of the loan, which is 3 years, and multiply that by the number of compoundings per year, which is 4, since we have quarterly compounding. So n will be 12. So we'll put an exponent 12 there. Now when we compute this, we have to make sure we're doing the proper order of operations. We have to do inside our brackets first, so we'll add this. Once we've added our bracket value, then we do our exponent 12, and then once we've done our exponent 12, then we can multiply by the 4,000. If we do that in the proper order, we'll get our future value of $4,782.47. So Nicole takes out a loan for an original amount of $4,000, and after 3 years, being charged 6% interest quarterly, She'll owe $4,782.47.